that can take place for a given scenario. Number. So today is going to be day one. We're going to talk about what we call permutations and combinations. And the overwhelming theme today is going to be how many different ways can this certain event happen, okay? And there's going to be some different things that we're going to do on our calculator to help us determine what that's going to be. The first part, we're just going to kind of introduce. There's 3 different things that we're going to do today to kind of figure this out. And then we'll do some actual examples with some scenarios in them as well. Okay, so the first one is what we call factorial. Okay, and it's a new symbol. If you've never seen this before, the factorial symbol is an exclamation point. So it's in exclamation point. And basically what we are doing here is we're finding out the number of ways I can do things. Like let's say I have 8 books, okay? And I want to take these 8 books and I want to figure out how many different ways can I arrange these 8 books on a shelf. Or if I have 7 shirts in my closet, how many different ways can I hang those 7 shirts in my closet and in different orders, okay? And so the way that we're going to figure this is it's going to be the product of all the natural numbers from n down to 1. Okay, so let's say that I have 3 books. I'll just do an example with 3 books just to kind of make an example of what's going on here. Let's say that we have a geometry book. Let's say that we have a history book. And let's say that we have a, Spanish book. Okay, 3 books. And I want to arrange those 3 books in different orders. So each one's a little bit different. Okay? Well, I could go geometry, history, and Spanish in that order, right? I could leave the geometry book first, and I could switch the Spanish and the history book, which would give me a different order. I could put the history book first, and then I could do geometry and Spanish. Or I could put the history book first and do Spanish and then geometry. Or I could put the Spanish book first, and then I could do geometry and then history. Or finally, Spanish first with the history, then geometry. Okay? Each one of those takes the same 3 books, but they're all in a different order. Okay? And so if I wanted to figure out how could I do 3 books, how many different ways, then this would be 3 times 2 times 1. We start with the number of books that we have, and I'm going to multiply every number all the way down to 1. So 3 times 2 times 1 is 6 different ways. And these would be the 6 different combinations that we would have. Well, we don't want to have to do this every time, right? That would be a lot of work and not a whole lot of fun if we had to list all the possibilities out to figure that out. But I just wanted to show you with a smaller group of numbers of how this works and what the different combinations would be. So if I had 8 factorial, I could do 8 times 7 times 6 times 5 all the way down to 1. Okay? But do we really want to do that? Do I want to take 8 times 7 times 6 times 5 all the way down to 1? That's going to take a while, right? So instead of doing that, we have this button called 8 factorial where I can do 8 exclamation point. And these 2 things are the same thing, but we don't have to do all the multiplication in there. Okay? So your exclamation point is going to be a little bit different depending on the type of calculator that you have. Some of you have a button that says PRB on it, and that's your probability button. And it's listed underneath that. Like if you have a calculator that kind of looks like this, you have to hit the number first, 8, and then you would hit the PRB button. You go over to the exclamation point, hit enter, and then hit enter one more time. 40,320. Okay, that's a lot of different ways. I could arrange 8 things. Okay, try to find that on your calculator. If you need help, I'll come around and help you out.
I've only been able to find it in capital. That's a 2. An S is a 5. Learn leap speed. Delete is up here. Or you can just type over. Guess what I am. It's kind of hard to get into it now, because I keep forgetting about it. So. Because I my explanation was there wasn't the whole
I thought it was too, but he said he doesn't think it was.
we have hair color.
Maybe it was. I know, I remember.
Just don't think I've ever seen anything like my color.
I don't think I've ever worn a dress before.
Fair enough.
Yeah, but
I thought there was that skirt that one
the
time.
number 2. Yeah. Could not tell you.
Not that I like pay attention to my career, of course, that would be.
I know I wear like just work as well.
Yeah.
I feel like speaking of same 2 shirts, I'm very dark.
You did?
I know, sort of. I don't know. This is almost like what happened. But I said
Team management.
So one of my favorite is the century split French speaking guy.
The one he originally had.
Japanese dude. Well, technically no, he's not Japanese.
Why is he French?
Genetics.
I don't think nationality is genetics.
You've got the same calculator as Pat, and I didn't know where it was. So she's trying to Google this. Search it.
Wait, the other thing, no, yours is way over. Ours was a read. Or the 5 ones, we'll get
I can even get this whole word on this paper.
Yeah, she's with me.
Oh, I think I know what it is. What's the context? What's the context? I think we were
The rest of the week, we're gonna have like this faded Oh, it's like
it's one of the special.
So do I. I just pulled up a YouTube video on my phone.
All right. Anybody else need help finding
You
that?
wanna know how many buildings?
Stop.
Okay, go to math, Hannah. Or hit 8 first. You got 8 in there already? 8.
Oh, I got a video to pull up. Well, I was just going around and
Okay.
to other people.
I was only able to find it in the catalog.
Oh, it's there too.
Yeah, it takes some scrolling.
That's a little bit easier, yeah. Okay, everybody else found it?
Fancy.
Okay, so that's the first button. We've got 3 different buttons we're going to talk about today. The other 2 are probably pretty close or associated with that one. So if we do 6 factorial, what do we get? 720. Okay. What if we had 13 items that I wanted to organize or rearrange? It's a lot, right? Okay. Anybody want to take a guess on how big that number is? What that number is? And I know your calculator doesn't give you the commas, but when I put the commas in there,
I don't like that number.
what number do you think that is? 6 billion. Yeah, 6,227,020,800. Kind of a few options, right? Anybody want to sit around today and organize 13 books or items? No, me neither. Try doing number 2 now, or 3. Now we're doing some operations with factorial. 18 factorial divided by 10 factorial.
I don't like that. The Sims not fun.
Another big one, huh?
Okay.
It'd be nice if calculators had a copy paste button.
You're not saying number.
Yeah.
Numbers, but you're not saying the number.
Okay, so once again, pretty big number. Okay, what if we did 0 factorial?
Put in the calculator and it said 1. going with 1. You go with 0. Whatever
Yeah,
you decide.
there's only one way to do that, but basically, here's the one way. If I have 0 items, can I rearrange 0 items?
I'm good for the
One way is no way, right? So really, you can't rearrange 0 items. So we really can't do 0 factorial. Okay. The next one we're going to talk about is what we call a permutation. Okay. A permutation, what we have to pay attention to here is order matters. And so when I think of permutation, I think of a place, and I try to use a P word, okay? If we ran a track meet, and let's say we had 20 runners, and I wanted to figure out how many different ways can those 20 runners finish first, second, third, and fourth, okay? If we're giving out 4 places. So placement matters, right? Who gets first, who gets second, who gets third, and so on matters. We're not just saying how many people finish the race, or how many different ways can I arrange those 20 people. We're saying what place they get, what it does matter, okay? Once I have somebody that gets first place, then I got somebody that gets second place, and it starts to kind of fill in as it goes. The way that we're going to see this in our calculator is NPR, okay? N is the total number of objects that we have, and R is how many placements we're gonna give, okay? So if I had a race of 20 people with, if I did the same example I just talked about, 20 P4, that means I have 20 runners, and I'm giving out 4 places, okay? That's what that is trying to tell us. We're not rearranging all 20 runners. So it's not just 20 factorial. The good thing for today is the formula for this, if we had to figure this out by hand, is n factorial over n minus r factorial. Okay? But we're not going to do that. Okay? Our calculator does that math for us. And so that's the good news, is I'm not going to show you the math. I'm not going to talk about the math. The calculators have that button on them, and so we're just going to use the calculator. Okay? If I did 8P8, or anything where these two numbers are the same thing, that means I am placing all 8 items. And so that's the same thing as 8 factorial. So if I did NPN, that means I'm going to place all n items, whatever that number is, okay? And so then we would do 8 times 7 times 6 times 5 all the way down. Okay, so on this one here, and I'm going to show you some different ways that you can do this, and we'll kind of talk about it. On the first one, how many different ways can we rearrange the letters in the word education? Okay, and the word education. First of all the letters have to be different, so we don't know any different between like this O and that O. And in the word education, we don't have any letters that are repeated. So that's kind of important, right? Because if I had 2 O's, which O is which? So because all of the letters are different, how many letters do we have in the word education? 9. So this would just be 9 factorial. The more items that we have, the bigger my answer is going to be. The more ways that we can rearrange those 9 items, or however many items we have. Okay, if I did number 7, we already kind of talked about the books on a shelf. If I have 7 books on a shelf, then it would just be 7 factorial. And so that would be 5,040. Hey, on number 8, we have 10 dogs in a dog show. How many different ways can we award first, second, and third place to the dogs in the show. So there's two ways that you can do this. Okay, one way you can do it is the permutation button that we used. You could just do 10p3. And if I do 10p3, what do I get? 720. 720 ways that all 10 of those dogs can place first, second, and third. Okay, another way that you could do it, and I'll do this at times because I think this is helpful to think about. If I was placing first, we're going to choose first place first, right? Who is the winner? How many different dogs can win first place? 10, okay? No dog has been picked yet, so I got 10 different dogs to choose from to get first place. After I choose a dog for the first place, how many dogs can win second place? 9, because somebody already won first place, right? Now there's 9 dogs left for second place. And then for third place, we have 8 dogs left. If I take 10 times 9 times 8, I would also get 720. So that's really what factorial, or in this case permutation, is doing, is it's limiting my options, right? We're not placing all 10 dogs in order. We're just doing the 3 and which place. And the order matters. What place they get matters. Okay, another P word that I like to use. And I like to use P words because it means permutation. Okay, in this case, 16 players on a hockey team. How many ways can a coach choose a captain and then an assistant captain? Okay. So we have 16 players, and we're choosing a position for them. Okay. In this case, it's captain, co-captain. Another one that you might see might be like a president, a vice president, and a secretary of a group. The certain position that they're filling makes a difference. Okay, because I'm going to choose somebody specific to do the president because I feel like they fit that job the best. Same thing would go for the captain on this one. So we have 16P2. Which would be 240. And the reason I show you the blank scenario here is I'm going to choose a captain from all 16 players. And once I've chosen a captain, now I'm going to pick a co-captain to go with them. And if I take 16 times 15, that also is 240. It doesn't matter which way you go. You get 240 either way, but I'm just showing you that this might actually be a little bit quicker than typing in 16P2, especially depending on the type of calculator you have, right? Where's the P button now? Okay, it's a good question. We hadn't talked about that yet. You want to look for the NPR button on your calculator. It's probably also in your PRB button. Same place that we have.
What? I didn't know that. I didn't know.
Okay.
I typed 16.
How many positions?
Okay.
Okay. Same place that we went on the other one. So we're going to go to 16, and we're going to go to catalog. We're going to go to probability. And we're going to go down to permutation.
Yeah, I got down there.
Okay, and then we're doing 2 places. Did you get that? Okay. Did you already take that 16?
Are you like a sprinter as well?
16. Catalog, probability.
That's it.
Permutation. Two places. Anybody else need help finding that? Okay, everybody's able to get 240? Find out where that's at on the calculator. Okay, I'm going to skip over number 10, go down to number 11 here. Using the digits 0 through 9, how many ways can Sarah create a 5-digit password if there are no repeating numbers? Okay, That means if I choose 9 as the first number in my password, I can't choose 9 again. And so I can only use it one time. If I did blanks here, it would be 10, and then 9, and then 8, and then 7, and then 6. And I would multiply all the first number in the password. I have 10 options, and then I have 9, and then I have 8, I have 7, I have 6, because I've already used a number each time. And that's kind of a long way to go on this one, so that one I probably wouldn't draw the blanks. On this one, it would be much easier to use the permutation. We have 10 digits to choose from, 0 to 9, right? 10 digits. And we're going to pick 5 of those digits to put into the password. Okay, so notice how I'm trying to use the words placement, position, pick, P-words, right? P-words that mean permutation. Order matters. The order that I put that password in. If I don't put that password in, I might have the numbers 1, 2, 3, 4, 5, but if I put in 5, 4, 3, 2, 1, am I going to get into my locker or whatever? No, okay? So I got to put it in a specific order. So order matters when we do a password. Okay? All right, so that is what we call a permutation. Permutation is where we have a specific order that has to be filled. On a combination, order does not matter. Okay, so if I have 5 books on a shelf, and I'm going to pick 2 books off the shelf. I don't really care what 2 books they are. I'm just going to pick 2 books to read. And I have to read all 5 of them maybe eventually, or maybe these 2 look the best, and I'm just going to randomly pick them. That would be a combination. Order does not matter. It doesn't matter what comes first, what comes second. I can read either book in either order. It doesn't matter. So this one is, once again, kind of in the same place as our permutation, but this one is using a C. And the word I like to think of here is choose. We're going to randomly choose 2 things or 3 things from a group, okay? I'm not putting them in a specific order. I'm just choosing 2 out of the group, okay? If I took a class of 24 students and I say, you 2 are going to come up here and work this problem. It doesn't matter who's first or second or whatever. I'm just picking 2 people at random to work a problem out. Okay? That would be a combination. I'm just choosing 2 people. Now, the formula here, and once again, the formula here is not something that we're going to do. I'm giving it to you because this is really what's happening when we do this. Notice there's more things on bottom. On the last one, it was n factorial over n minus r factorial. Now we also have r factorial on bottom. And so we have more things on bottom. So we're going to have less options here, okay, when we do this. And if I have 5 books and I choose all 5 of them, there's only one way to do it, because I'm going to take all 5 books off the shelf and I'm going to read them all, okay? And so if I choose all 5, there's only one way to do that, and that would be taking them all off. Hey, there are 12 math teachers at a school. It's a big school, 12 math teachers. Holy cow, huh? And how many different ways can the 5 of the teachers be chosen to attend a conference? So the school's going to come to them and say, I need 5 people to go to this conference. I don't really care the order that you're in. I'm just going to, 5 of you need to go. And so we got 12 teachers. We're going to choose 5 of them. There's no placement, there's no order or anything like that. Just random order. Okay, your C button should be in a very similar spot to your other 2 buttons, depending on the calculator you have. Everybody's got a little bit different calculator. So it should be easy to find. You got factorial, you got permutations, and now this is the 3rd one, which is what we call combinations. Okay, you go to a frozen yogurt shop, an ice cream shop, and you have 8 toppings, and I'm going to pick 2 of them. Okay, once again, order doesn't matter. I'm just going to say, I'm going to look at the toppings, I'm going to say I'm going to pick those 2. I want those 2 those 2. Bryson, you all right?
Yeah, that'd be
28. Okay. I'm going to skip 14. Number 15, 33 students, and we're going to choose 5 of them to make a smaller group out of the 33 students on our roster. Okay. And if I did that with a permutation, that would be a huge number, okay? Because I'm lining all those 5 people up a lot of different ways out of a group of 33. So that'd be a lot of people, right? Bigger number's always first. Yep. Because if I have 5 people, can I choose 13 out of those 5? No, that would, yeah. So good question. The bigger number always has to come first. Okay. And then let's jump down to number 17. You got 5 questions on a 30-question math test. How many different ways can he choose the questions he wishes to answer? So we got 30 questions, and I'm going to choose to omit 5. And notice a lot of times it keeps using that word, choose, right? We're not placing, you got to really read these carefully, because in just a second we're going to do a couple where we have to determine which one of these we have. Look at your homework packet. And on your homework packet, you have a page that says permutations or combinations at the top. Okay, I'm going to pick a couple of these to do, and then we'll probably do a few more of these tomorrow as well. Okay, permutation or combination. Some of these could be factorial as well. Okay, if I have 11 students and we're getting ready to go to lunch and I want to line those 11 students up on number 1, how many different ways can I align 11 students up in a line so we can walk to lunch? What would be the best thing to do there? The exclamation point. Yep. So I would do 11 factorial. Or I could do 11p11, but the exclamation point would be better there because we have a specific placement. We're putting kids in a specific order in the line. Okay, and it's a pretty large number. Okay, let's look at number 2. How many ways can Leon choose 4 toppings to put on his pizza from 13 total toppings? So he's ordering a pizza that maybe the pizza place says you can only put 3 toppings on. And he has to choose his 3 favorite toppings. And it doesn't matter the order that we put it in. So we know we're going to choose from 13 toppings. Does order matter here? No. Okay, I'm just choosing 3 toppings from the 13, or 4 toppings from the 13. So that would be 13C4. That's where these get a little bit tricky, is we have to decide, does order matter or not? That's the question you're going to ask yourself. If order matters, it's a P. If it doesn't, then it's a C. Okay? And so this would give me 715 ways. Okay, jump down to number 6. Let's actually I'll do 7 first and then we'll come back to 6. So let's look at 7 first. 16 people tried out for a musical for the lead. How many ways can the director select a lead and then an alternate for the lead? Okay, so is there a specific placement or position that's being filled? Yeah. Whoever gets the lead, right? They're not just going to randomly choose. Usually if the director is going to choose, they're going to probably pick the person they feel is the best person for that job, right? And so we have a specific position to fill. So we have 16 people, and we're going to pick or place 2 of them. You've got to fill the lead and then somebody that's going to be the alternate or the understudy. Okay, so that is where, and it may not say in there, it's not going to tell you, hey, this is a permutation, right? But because we're filling a specific position, we know that that means P. So that's, once again, where we go back to the P words. Pick, position, placement, something is being filled. Okay, now number 6 is a little bit tricky. It's talking about the words, or the word Pennsylvania and the letters in the word Pennsylvania. How many letters are there in the word Pennsylvania? Okay, there are 12 letters. But if I'm trying to choose a 5-character password, are any of the letters repeats? Yeah, how many letters repeat? Okay. Okay, that's right. There's 3 N's and there's 2 A's. Okay, so how many different letters do we have to choose from? Because I don't know, like if I pick an N out, I don't know which N it is, right? If I pick an A out, I don't know which A it is. How many different letters, Ryan? 9. Okay, so there's only 9 different letters to choose from. We're not going to use all 12 because there's no difference between the 2 A's or the 2 N's. So this one's a little tricky, right? So I got 9 letters to choose from, and we're going to make a password, so order matters, and we're going to pick 5 of those letters to make a password. Okay, so here's what I want you to do today. There's 2 parts to your assignment today, okay? I want you to finish this page, and we're going to talk about this tomorrow. So this is the first thing you should work on today, because we're going to kind of go over these tomorrow. And you have to decide, what of the 3 am I going to use? Am I going to use factorial? Am I going to use C? Or am I going to use P? Okay. The second part of your assignment is homework 7, but only the first 14.